Dinosaurs have often been depicted in much of classic paleo art and popular media as inhabitants of balmy, tropical climates, in lieu of the traditional association of reptiles with jungles, and the Mesozoic is usually considered to be one of the warmest periods in Earth's history, with high levels of atmospheric carbon dioxide, average temperatures reaching 10 degrees Celsius higher than those of today, the lack of any polar ice caps, and the widespread presence of conifer or deciduous forests, including ones which grew at both the North and South poles. But research made over the past few decades has shown that the era's average temperatures rose and fell over the course of millions of years, and that it did see its fair share of cooler, colder climates and temperatures or periodic winters with ice and snow, especially at high latitudes or at the poles, which witnessed approximately 6 months of continuous sunlight and another 6 months of harsh winter darkness, and that the dinosaurs were uniquely adapted to cope with and thrive in such conditions, given the endothermic or warm-blooded metabolisms of many taxa and the presence of feathers or feather-like filaments, which insulated the members of some groups, such as the theropods and ornithischians, and certain places in the Mesozoic fossil record which highlight the incredible ability of these remarkable reptiles to survive in high latitude or polar climates, include the presence of fossil trackways which date from the late Triassic to early Jurassic of northwestern China's Junggar Basin, the Jurassic and Cretaceous formations of Antarctica and southern Patagonia, the early Cretaceous Yixian formation of China's Liangling province, the Cretaceous formations of Australia, and the late Cretaceous Prince Creek Formation of Alaska. It is true from recent phylogenetic studies that the hypothetical common Archosaurian ancestor of dinosaurs, pterosaurs, and crocodilians, which emerged during the early Triassic, may have possessed a layer of fuzz-like pycnofibers, or protofeathers, which was later passed on to the pterosaurs and the ancestors of the Saurischian and Ornithischian lineages, and this unique feature might have enabled the dinosaurs to survive the changing climate and extreme temperatures of Pangaea, the higher latitudes of which may have had freezing winter temperatures, while most other archosauriform reptiles, such as the atosaurs, phytosaurs, and rauisuchians, were still heavily scaled and largely confined to the tropics. This became evident when a series of volcanic eruptions, which accompanied the breakup of Pangaea during the Triassic-Jurassic extinction event around 201 million years ago, spewed forth great quantities of gas into the Earth's atmosphere and led to the demise of 3/4 of the world's terrestrial and aquatic fauna, including nearly all non-insulated tropical reptiles, with the notable exceptions of the ancestors of modern crocodilians, the tuatara, and the ancestors of modern turtles, snakes, and lizards. While the dinosaurs were traditionally thought to have been able to survive the extinction by adapting to the spike in atmospheric carbon dioxide and rising temperatures as tropical creatures, a 2021 paper from an international team led by the American paleontologist Peter Olson presented a new theory on their evolutionary success after the Triassic, based on a remarkable discovery from northwestern China's Junggar Basin, which records the earliest possible instance of dinosaurs surviving in cold climates in the form of fossil rocks that date to around 206 to 193 million years ago during the Triassic to Jurassic transition, and include geologic signatures of ice, such as ice-rafted debris. This indicates that the area in which these early polar dinosaurs lived was situated high above the Arctic Circle, despite being forested and had freezing temperatures and lakes which are covered in ice. And Olson's team went on to conclude that a haze of highly reflective aerosols emitted by the volcanoes might have had a temporary cooling effect, which the endothermic and well-insulated dinosaurs were suited for, and that the massive eruptions of the Triassic-Jurassic extinction event triggered lowered light levels and volcanic winters, which killed off much of the non-insulated tropical reptiles, but enabled the dinosaurs to survive and undergo a truly rapid, expansive radiation into the early Jurassic across much of Gondwana and Laurasia, as Pangaea continued to break up with a surge of tectonic and volcanic activity. Throughout much of the Mesozoic, Antarctica, as well as much of the rest of Gondwana, had cool, temperate, evergreen forests of gymnosperms that were quite similar to the ones of present-day southern Chile. The Hansen Formation dates to the Pliocene stage, or around 194.6 to 182 million years ago, and records a humid floodplain environment that was situated in the middle of a rift valley and was heavily affected by frequent volcanic activity and forest fires. The formation's diverse inhabitants included basal, crow-sized pterosaurs that were related to Dimorphodon, Tritylodont synapsids, small basal ornithischians, the prosauropod Glacialosaurus, as well as relatives of Massospondylus and a large basal sauropod, a coelophysoid theropod, and the large comb-crested theropod Cryolophosaurus ellioti, which is by far the continent's most famous non-avian dinosaur. The Jurassic period so far did not see any ice caps forming at the poles, and even though much of the early Cretaceous, the time of Iguanodon and Psittacosaurus, had a climate that was overall warm and humid, with maximum greenhouse temperatures reaching 32 degrees Celsius or 90 degrees Fahrenheit during the mid-Cretaceous hothouse, there were still a few areas situated within higher latitudes that had cooler and more temperate climates, or even the occasional freezing winter. Studies of oxygen isotopes from the early Cretaceous Yixian Formation of China's Liangling province, which dates to the Permian age around 125 to 124 million years ago, and records the presence of a forested environment that had several lakes and ponds, and was sometimes impacted by volcanic eruptions and forest fires, have shown that its average yearly temperatures would have reached 10 degrees Celsius and are indicative of a temperate climate with unusually cold winters due to the high latitude of northern China at this time. And a 2013 study has also found out that the area's climate fluctuations would have also been influenced by orbital forcing, or the impact on climate caused by shifts in the tilt of the Earth's axis and by the shape of the Earth's orbit, the same process which would later go on to cause some of the major glaciations of the Pleistocene. And the fossils of the many Coelurosaurian dinosaurs found in the area, such as those of the dark-colored oviraptorid Caudipteryx, the fuzzy therizinosaur Paleo-Files, the ginger-colored compsognathed Sinosauropteryx, and the large tyrannosauroid Yutyrannus, also show that they were all well-feathered and insulated enough to withstand the Yixian's cold winters. The southern landmasses, which are situated around the South Pole in an area known as the Vadolian Biogeographic Province, which was dominated by forests of conifers and other gymnosperms and landscapes that were similar to those of modern-day Chile's Conguillo National Park, New Zealand or southern Patagonia, were not immune to the occasional frigid cold, ice or snow of higher latitudes, even though the temperate climate would have overall been quite warm, as evidenced by the presence of temnospondyl amphibians and ectothermic reptiles. Australia, for instance, was situated far closer to the South Pole than it is today, and it would have experienced freezing temperatures at times, especially during the winter, as well as being partly engulfed in the middle by the great, expansive, and icy inland waterway that is the Eromanga Sea. During the Albian Age, around 112 to 100 million years ago, the Alaru and Tulobek formations recorded a coastal, forested wetland at the edge of the sea that was inhabited by the symphospondylin sauropod Ostrosaurus, the 8-meter or 26-foot long, 2.8-ton ornithopod Matabarosaurus langdoni, and the ankylosaur Cumbarosaurus ieversi, which is the most completely preserved thyreophorine ever to be found in the southern hemisphere, and would have relied on oral processing to digest its food of ferns, fruit, and rigorous or vascular plant tissue. and the waters inland may have had sheets of ice year-round and were inhabited by sea turtles, elasmosaurid plesiosaurs, Pictosaurid platypterygius, mackerel sharks, and the fearsome 9 to 10 meter long pliosaur, Kronosaurus queenslandicus. The contemporary Umarola Formation, much of which is preserved in the famous Dinosaur Cove locality, was home to a diverse array of elasmerian ornithopods, such as Leominosaura and Quantosaurus, as well as other kinds of dinosaurs and megaraptorans such as Australovenator. Towards the very end of the Cretaceous, the Weddelian biogeographic province, which was represented this time around by the Lopez de Bertodano and Snow Hill Island formations of Antarctica, as well as the Dorotea Formation of Chile, was home to elasmerian ornithopods such as Morosaurus, Talankawan and Trinisaura, Parankylosaurs such as Antarctopelta and Stegosaurus, hadrosauroids such as Gonkokan, titanosaurian sauropods and theropods such as Microraptorans, various birds, and the unalagine Imperabator, and its cold, deep waters were teeming with ammonites, such as the bizarre, paperclip shaped Diplomoceras, sharks such as angel sharks, frill sharks, and goblin sharks, and plesiosaurs, such as the giant 12-meter long filter feeder Aristonectes and its kin. And perhaps the most famous locality which records the presence of Arctic dinosaurs, as well as the high latitude location where they managed to reach the farthest north of their geographic range, is the Prince Creek Formation of northern Alaska, which dates to around 72 to 69 million years ago during the Maastrichtian stage of the late Cretaceous, and was home to herbivores such as Edmontosaurus regulus, the Ceratopsian Pachyrhinosaurus parodum, the Pachycephalosaur Alaskacephalae, and close relatives of Leptoceratops and Basilosaurus, as well as carnivores such as Dromaeosaurids, a giant undescribed species of troodontid that was 50% larger than its southern relatives, the Tyrannosaur Nanoxaurus, and a variety of bird species such as relatives of Hesperornis and Ichthyornis. The area's depositional environment represents a taiga-like temperate boreal forest of spruce-like conifers and deciduous angiosperm trees, with a canopy of around 5 to 6 meters, or 15 to 20 feet tall, and an understory of ferns and horsetails that was situated upon a coastal network of floodplains, lakes, rivers, and wetlands that somewhat resembled the bogs of present-day northeastern Europe. Although the area's overall climate was similar to that of many other late Cretaceous North American formations, as well as present-day Iceland, it sometimes saw sudden drops of temperature during the growing season of around 6 to 10 degrees Celsius that are indicative of subarctic summer conditions, and the area may also have had overcast skies and frequent rainfall, since it would have had a mean annual precipitation rate of around 1,300 millimeters. And since the area was situated around 80 to 85 degrees north, high in the Arctic Circle, the Prince Creek Formation would have also experienced 120 days of winter darkness, with freezing temperatures and occasional snowfall during the cold winter months. Moreover, the absence of fossils of many ectothermic animals, such as amphibians, crocodilians, squamates, and turtles, also attests to the freezing temperatures that the dinosaurs, mammals, and other ectothermic creatures all had to endure. It was traditionally assumed among many paleontologists that the bigger herbivores of the Prince Creek Formation, such as Edmontosaurus and Pachyrhinosaurus, might have embarked on a 3,200 kilometer journey south to escape the winter and return north with the onset of spring. But a 2021 study from Pat Druckenmiller and colleagues, built upon 3 decades of field excavations, that revealed the fossil teeth and bones of countless baby dinosaurs, has doubted this hypothesis, and instead suggests that the area's polar dinosaurs were year-round residents of their Arctic environment, whose nesting cycles and offspring were affected by the changing seasons and shifting light conditions and variations in seasonal temperatures, which would have placed significant constraints on food abundance and their ability to raise their young and to survive the cold Arctic winter. Since temperatures which are safe for egg incubation spanned just 7 months during the daylight hours, or days and weeks, and it took a prolonged 2.5 to 6 months for the bigger-bodied dinosaurs to incubate their eggs, it is likely that they would have used the narrow window provided by the 15-day February to March sunrise and the beginning of the productive spring months to build their nests, lay their eggs, and incubate them for much of the limited 6 to 7 months of constant daylight. Their hatchlings, which may have preferred to stick around coastal areas, would emerge in the middle or tail end of the Arctic summer, with either a few months or weeks to find enough food before the 15-day sunset marked the onset of the darker, colder autumn and winter months, which would have seen the smaller herbivores entering a state of torpor in their burrows, and the bigger herbivores, such as Admonosaurus and Pachyrhinosaurus, either fasting or sustaining themselves on the limited, low-quality forage, such as bark, ferns, horsetails, and moths, until the arrival of next year's spring. As some of our planet's greatest evolutionary success stories, the dinosaurs have been able to eke out a stable living for over 165 million years at the highest latitudes or at the poles, where colder temperatures, 6-month cycles of sunlight and darkness, and occasional, periodic winters prevailed, thanks to their endothermic metabolisms. The feathery insulations of many species, such as the coelurosaurian theropods, or some ornithischians, which kept them warm in colder temperatures, and unique reproductive strategies from taking advantage of the most seasonally productive times of the year. And these remarkable adaptations can still be seen in some way or form with the archosaurs of today, such as the American alligator, which can regulate its body temperature or breathe from a hole in the middle of the ice during the winter months, and the birds which thrive at higher latitudes or at the poles to raise their families there, just as much as their ancestors and relatives have done 66 million years earlier.